University of Nottingham. If you don't know Bob Laramie yet, he received a bachelor's degree in physics, which is a good choice, studying like this. Me as well. From the University of Massachusetts, Amherst, and he got a master's in computer science from New Hampshire. And then he did something strange, he moved to Austria.
Are you Austrians here?
Of course. And he got a PhD, I think, in 2005, yeah, from Jena, the visualization group we all know about, Eddie and Meister and all of the stories, yeah. But as we found out, we actually met even before, because you worked during your PhD. You worked for the VISUS, for the Vienna Research Center for Visualization and Virtual Reality. And you worked there, I think, from 2002, and I became scientific advisor board member in 2004. So we met more than 20 years ago already. So after Vienna, he moved to Swansea, and this is where you became visible in the field as the co-organizer of the Eurovis 2014, was it 14? Yeah, I remember. Yeah, and after quite some years in Swansea, where you moved up the ladder from lecturer to associate professor, you moved in 2020 to the University of Nottingham, where he is now a professor of computer science and visualization in the Faculty of Science School of Computer Science. This is what I know about you. Nice. So Bob's research interests are in the areas of scientific visualization, information visualization, visual analytics. Is there anything else?
But isn't scientific visualization dead? Sorry, we keep that.
He has published more than 200 papers, I think 20 in TVCG, I looked it up, and 12 CGF, so quite a well-published colleague. He has served our community in many roles, as I said, co-chair of Eurovis, I think, co-chair of Topi in VIS, and co-chair of the British thing, what's it called?
UK, the chapter chair.
Okay. So, and as an editor, associate editor of CGF, so all roles you can think of. And today he talks about the value of overviews, and I will not give an overview.
I'd like to just start off by saying thank you. Thank you for inviting me here. I really appreciate it. It's my first time in Stuttgart, so it's an honor and a pleasure to come here and talk.
Oh.
So talking, I see talking here as a bit of a crisis because I'm usually the expert in the room, but this is not, I don't see this as the same situation actually. I'm not sure that's true anymore. So to compensate, I'm going to do a few things to compensate for that. This talk is going to be a little bit less scientific because I can't out-scientific this crowd. Also, another thing I'm going to do is I'm going to give the crowd, the audience, some quizzes, right, to try to balance this this imbalance. And I think I'm old enough now that I can give some opinions, so that it's more like a viewpoint. It's not as scientific, this talk. It's more like the title of this talk could be something Bob was thinking about while he was sitting in the corner. Like, it's not as scientific. So I'm going to offer some opinions, and I'm going to try to back up the opinions with some evidence. And there will be no AI or machine. Yeah. So you knew this photo was coming, right? You knew, you knew somehow.
But you promised to delete it.
I'll delete it after this talk. So quiz number 1. Quiz number 1, just for fun. Does anybody know where that's from? There are two people in the room that should know where this is from. It's just two people that should know where that's from, right?
Looks like you
There's a hint. There's a hint in there if you guys want. The hint is here.
Yeah.
Anybody know where this is from?
I think it's Eurographics in Saarbrücken.
Yes.
2010?
2002.
2002.
2002. So I think this is the first time I saw you, and I think this is the first time I saw Daniel. I went to this tutorial.
Okay.
And this was my first sort of, I think it was my first kind of, not Viz conference, but Viz directed conference, let's say. So that was the first time I met. So it's a history. There's some serious history here. And a very quick, useless, completely useless story. I was sitting in the audience, and about 15 minutes into the tutorial, Dan Bergeron walks in. I don't know if you remember that.
I remember Dan Bergeron.
Anyways, he comes into the room, and he sits right in the front. And Dan Bergeron was my master's thesis supervisor, and I had already moved to Austria, and for me it was like, oh wow, I see like my master's supervisor coming all the way to Germany, how exciting. And about 15 minutes after he got there, he started to fall asleep right in the front row. And I was like, if you're gonna fall asleep, don't sit in the front row, like sit in the back.
I already apologize.
Anyway, useless story. I know.
But since I'm retired, it's remarkable to see here that 2 out of those 8 became professors.
That's amazing. Yeah, that's amazing. Yeah, quite a piece of history. I think it's also interesting that it's
That became not 6 out of 8. I'm sorry.
That's right. That's just amazing. Okay, some more just for fun slides. There's no quiz here, but I had a theory. Well, I could say, can anybody name the years? That would be very, very difficult. The years are down here, if anybody's interested. But I had a theory that if I got my brain like close enough to Tom's, I could get some of the brain waves, like maybe raise my intelligence a little bit. But it didn't work. There's one very, very low quality photo in there. That's there because it's from 2014, which is a special Euroviz 2014 photo. Here's a little quiz. Anybody want to guess where this is from? Where these are from?
Well, the people who are remotely connected should know.
I guess only you could know this. Daniel might know that.
Daniel, well,
I think.
Maybe Kauser might know.
Yeah.
Say that again?
David Hauser might know.
Yes, yes. Can any?
And Alex Teleo here.
Can everybody spot Tom in that image somewhere?
Yes.
There you go. Yeah.
This is Euroviz 2004 in Constance.
Good. Yes, correct. You passed. You passed the quiz. Yes. Those are the oldest photos I have, which is pretty old. It's pretty old.
Look how well they were dressed.
Yeah, I think that's like the Schmetterlings Museum or something like that. Something like that.
It's Ertl mine now, yeah.
Ertl.
You can read it on the right. It's Schmetterlings.
Does it say it?
Yeah.
Oh, okay. Oh, right, there it is. Yes.
But you need to pronounce it how that's German.
Okay, I'll stop talking about something. So it's called the Value of Overviews, the name of this. And this is something that only as far as I know, I'm the only person thinking about this. It's like just my own little perspective, yeah? So this is inspired by a conversation with a rebellious PhD candidate. I was reviewing a paper that he's writing and he's working on, and I made the comment, this paper would benefit greatly from an overview. And by the way, I write that all the time. So if you see if you see a review, and his reply was, "I don't see the value in it." And I almost had a heart attack. I was like, "How can you not see?" You know. So that's how this started, and it got me thinking more and more and more about it, basically. And so it's the same as this overview. So it's the same overview as the overview first, filtering and selection and details on demand mantra. So the basic opinion here is that overviews are the holy grail of visualization. So I'm sticking my neck out a little bit here. So the overview component is the most important, it's the most in demand, it's the most challenging, and therefore it's the most interesting and inspiring. Like trying to get an overview. It's inspiring, and it's inspiring for a lot of new visualization research papers, for example, for new publications, right? And the importance of overviews cannot be overstated. That's the basic premise. That's basically what we're going to talk about. And feel free to interrupt or raise your hand or have a discussion or have an opposing opinion. As long as it's polite, it should be fine, right?
Sorry, you're German.
So why overviews, right? Why are they so interesting? And this is I can't argue this really scientifically, so I have to argue this or present this anecdotally and with evidence, right? So one of the inspirations behind this is a collaboration with a company called QPC. So they're based in Birmingham, and they develop software for call centers, the operations of call centers, and their database records every event inside of a call center. So for example, when a call was placed to the center, the phone number, the different options that the caller chooses when they navigate this interactive menu, how long they're put on hold for, what agent they talk to, what the result of the call is, was their problem resolved, were they passed to another agent, did the agent make a consult call to another agent, and so on. So it's a complicated database. It records millions of events inside of a call center. And they asked us if we could help them visualize and analyze the call center data. It's really a challenging problem. And one of the comments that one of the call center or the analyst from QPC said is just, to be honest, we just want to know what happened. So they collect all the events, and they just want a starting point, and they want to know what happened in the call center. That's like the most fundamental question. And one of the things we also noticed was QPC was unable to create an overview. Like, this is a problem that they couldn't solve. And part of my thesis is that this statement, to be honest, we just want to know what happened, is an implicit statement of we wish we had an overview. Like, we really want an overview of the data, right? So we made some attempts, right? Let's see, this is one attempt. Let's see if this works. This is the first time I've put YouTube videos inside of Google Slides, so I hope it works, right? We tried to build a tree map overview of the call center data. So we divided, the tree map is based on time, actually. So there are some different snapshots of the tree map, and we'll see some interaction with the tree map very shortly. But you can see there are 24 squares here, and each one of those squares represents 1 hour of time. And then the volume of data inside the square represents the volume of calls in that hour. Right? So at midnight, there aren't many calls to the call center. But then suddenly at 7 a.m., the volume of calls increases, at 8 a.m. and 9 a.m. And then the color is mapped to the number of abandoned calls. So this is the worst case scenario for a call center, is somebody calling up and then hanging up before their call is resolved, right? So this is an attempt for us to create some sort of an overview of all the activity inside of a call center, hour by hour. And you can see that for some reason during this hour, a lot of calls are abandoned, right? That's indicated by the red color. And then, so this is the overview. This is a histogram, also of a volume of calls, hour by hour. And then there are a whole bunch of filtering and selection options over here, right? So there should be, so there's, one of the things we tried to implement is a smooth zooming in and out. So this is 1 hour, and then this is all the calls inside of 1 hour, right? You can see each individual call. And then the volume of the rectangles, or the area of the rectangles, indicates the length of the call, right? So if there's one that's very long, it will show up as a big rectangle. And the color, again, indicates that this was an abandoned call. So that's a really bad, well, that's the worst case scenario, a long abandoned call. And I believe this one has about 300,000 calls, so it's approximately 300,000 calls inside of one day, right? And then we tried to have this kind of smooth zooming in and out of the hours. So another attempt at an overview. That previous example is a call-centered lens of the data. This is an agent-centered lens on the data. So the focus is on the agents and the agent behavior inside the call centers. And one of the goals is to find out which agents perform the best, right, in which departments. So in this case, the color coding represents the department that the agent works in. This is a scatter plot and a scatter plot matrix for the different variants inside the data set. And they also want to see agents that are very deviant in their behavior, right? There are some agents that play games, like they'll just pick up the phone and they'll put it to the side and they won't do anything, right? Or the caller will hang up. This is a trick that I see actually in my own experience too. The call will end, but the agent won't hang up because they know as soon as they hang up, a new call will come. So they just leave the phone to the side. You might notice that next time you look out for it. So we tried to represent the agents with glyphs, right? So each agent is a glyph, and then there are certain properties of the agents, how long their average call duration is. Their average, something called the customer effort score. So that's a quantification for how much effort each customer had to go through in order to resolve their call query or their call problem. Net promoter score is a quality metric. The cost of the call, right? Each call has an associated cost and then a total cost, right? And you can map any two of these variants on the scatter plot, like total number of holds versus the average customer effort score, right? And then you find out that there are some strange agents in there, right? Like an agent that creates a lot of work for the customers, but has no holds, like some very, very strange ones, or agents that put callers on hold, like every single call, for example. So there's a lot of occlusion there, and that's why we tried to create a hierarchical glyph structure to cluster the agents together and then zoom in and out of the hierarchy. This is not yet the clustering algorithm. This is just showing what it would look like without any clustering and without any hierarchy. So this is our attempt at trying to get an overview of the agent behavior inside of the call center. This is basically an attempt at doing that. So now we can cluster the agents together, and then these segments around the cluster represent the number of agents belonging to that department, right? So tech support and so on. So there's a lot of agents in the billing department in this cluster. Right? And then all of these metrics are the same, but they're just averages, right, for the whole cluster. And then you can zoom in and out to get arbitrary levels of detail until you get down to individual agents. So it's an attempt to get start with an overview and then apply some filtering and selection. And oh, wrong button. Okay, another example, and this is a quote I remember from a long time ago when I was at VISUS. I remember one of the engineers saying, we start by examining the surface in an attempt to get an overview. So this is an example from computational fluid dynamics, right? Some people here are looking at the computational fluid dynamics data. And we collaborated with a company called AVL. Anybody heard of AVL? Okay, nice, nice. And this is what one of the engineers said. We start by examining this, so they start their visual exploration with a surface. And this is an algorithm we worked on to get, basically to get an overview, right? That's the advantage of these texture-based techniques, right? I'm going to show, so Daniel doesn't get too bored, I'm going to show some imagery that wasn't published at that time. So the advantage of this texture-based flow visualization technique is it provides an overview. That's the basic advantage that it gives. In this case, it could be unsteady data. So you have your surface. This is blood flow inside of an aneurysm, right? And we can get some sort of an overview. As opposed to the more, I don't know, you could call them the more classical flow visualization techniques based on things like streamlines or glyphs, right? Because you have this seating problem or this placement problem with the glyphs and the streamlines that you don't have. You avoid that problem by using a texture-based technique that tries to provide an overview of the whole surface. Okay, I won't go through the whole videos because the video I will run over time. So I'm just going through some of the videos or some subset of the videos, but all of the videos are on YouTube. So if you want to see the whole thing, you're welcome to have a look at the whole thing. So another example is a collaboration with marine biologists. I could quiz you on this one, Tom, to see if you remember this. This is not going to be easy, but you could remember this.
What would be the question?
The question is, can you remember this?
No.
Was this with Colin Ware?
This is not with Colin Ware, actually, but that's the answer to a different question.
Okay.
So, good memory. So in this case, this was a collaboration with some marine biologists, and what they do is they go out into the wild, which is already pretty scary, and they capture wildlife, actual animals like cormorants or penguins, and anything that dives deep underneath the sea surface. And they attach sensors to those animals, and the sensors record local variables like acceleration to try to understand the motion of the animal, pressure, so the deeper they dive, the higher the pressure, the temperature of the water, or the local temperature, and the amount of ultraviolet light reaching the sensor as well. So they capture the animal, attach the sensor, they might even attach multiple sensors, release the animal into the wild. Then the sensor records them for a few days, could be a few hours, could be a few days. They try to capture the same animal again, which obviously doesn't always work. And then they collect the sensors, bring the sensors into the lab, and they have days worth of time series data. Days. And then they manually look through the time series data to try to find patterns and try to derive the behavior of the animal while it was underwater. Right? Any memories coming back, Tom?
Yes.
Yeah.
Yeah.
I told you there would be quizzes.
Yeah.
Can you remember the year?
Well, I saw 2009.
I know. Oh, there was a alright. Yeah, there was a 2009 in there. So, anyways, this is the overview. I would call this a failed attempt at an overview. So, like immediately at the time, I wasn't obsessed with overviews, but I remember thinking, oh my gosh, how can we get an overview of this data? How do you get an overview of time series data that's a few days long? Like, how is that possible? And I would call this a failed attempt at trying to get an overview. We didn't state the problem in those explicit terms, but I remember thinking that, like, oh, I really wish I knew how to get an overview of this data. And I think if we read the paper, we call this the overview. But it's not really an overview. It's a failed attempt at an overview because it doesn't show the entire data set, right? It's a few hours or maybe 1 hour. And then the user can select a focus window inside the overview, and then the focus appears here. These are the 3 axes of the triaxial accelerometer data, and then we reconstruct them in a polar coordinate system so we can get them in their more natural orientation, right? So we can see which direction is north, which direction is south, which direction is east-west. So this is an attempt to get an overview, right? A polar histogram, trying to get a summary of all the different orientations of the animals. But I would say it's interesting, but it's really unsatisfactory. It's not a proper overview. And I would call this an unsolved problem. Like, I haven't seen overviews of time series data that I consider to be the solution to the problem. I haven't seen that yet. But it's interesting, at least. So that's a histogram of velocity. So we can derive, for example, the knowledge that the animal that this was attached to spent a lot of time in that orientation, right, from those long bars. And this is a clustering algorithm. And like all clustering algorithms, what are they trying to do? The objective of a clustering algorithm is an attempt to get an overview, really. So we try to put all of the posture states into clusters and then represent those clusters with some sort of, could be points, could be spheres, could be a distribution, and so on. Oh, I keep pressing the wrong button. Oops. So that's a failed attempt at an overview. And so I was thinking about this in the corner, as I usually do, and I thought, this is really a pattern here. This is a pattern. It's not just one collaboration or 2 collaborations or 1 company or 2 companies. It's everybody. Like, everybody I've worked with has struggled with this problem, right? It doesn't really matter who I worked with. So one of the basic hypotheses is we just want to know what happened implicitly translates into we would like an overview. That's what the visual interpretation of that is. And that's been my experience with every collaboration. I can't think of any exceptions.
Can I ask you a question? How do you define overview?
I haven't thought of that. But off the top of my head, some visual representation that reflects all of the data in the data set. That would be my knee-jerk reaction. It doesn't leave anything out.
It's not related to tasks.
It's not related to what?
Tasks.
Tasks. You could, you could argue it's related to exploration.
Okay.
That's usually kind of the general term for
Okay, good.
overview, starting with an overview for exploration.
You could make the arrow bidirectional then. Once you have an overview, you know what happened.
Yeah.
There we go. That's part two. That's my next talk.
Okay, sorry.
There's an implicit agreement there, which is cool. Okay, so that's some anecdotes, personal anecdotes. I'm going to try to make this point a little bit more persuasive, just from a more general standpoint. And the basic idea is that a lot of the popular visualization techniques are popular because they provide overviews. So I claim that one of the reasons LIC is popular is because it provides an overview. Right? It's not maybe the only reason, but I claim it's one of the reasons. I think the aesthetics is another reason, but it's overview is one of the reasons too. I claim that tree maps, one of the reasons tree maps are so popular is because they provide an overview. And they also have the special property of being scalable, right? I haven't talked about that, but that's a special property that tree maps are over. Does anybody recognize this, by the way? The S&P 500 tree map? Anybody look at that besides me? Am I the only one?
Okay.
Really? Nobody looks at that? I'm the only one? Okay. It's okay.
Every now and then, if I need an example for
Okay. Anyways, that's from
Look how
Fin.
small NVIDIA was back then.
That's in from the finviz.com website, if anybody's interested. I also claim that things like edge bundling and clustering are popular because they are attempts at providing overviews of something, right? I would say edge bundling is a special kind of clustering. But the reason clustering is so popular is because it's an attempt at providing an overview, and it's a scalable overview as well. That also makes it very popular. And volume visualization, the gradient-based volume rendering, the gradient-based transfer functions, I claim that one of the reasons they're so popular is because they're one way of providing an overview of volume data. Not the only way, but a good way. Parallel coordinates, I claim that one of the reasons they're popular is because they provide an overview. In this case, maybe there's a scalability. They don't really address the problem of scalability. We tried to do that, by the way. We tried to make parallel coordinates more scalable. But one of the reasons they're so popular is because they provide an overview of multivariate data. And so the basic claim here is the most popular visualization research papers provide an overview, and this is one of the main property that makes them so popular. That's the basic claim, right? And I tried to look for data to support this hypothesis, but in the given time I failed. I couldn't find actual data in raw numbers and statistics or some more quantifiable evidence for this claim. I'm just going to throw it out there based on experience. Like I Googled, most highly cited visualization papers, but I didn't find a hit actually. You can find like most highly cited papers, period, or most highly cited chemistry papers, and things like that. But I couldn't find a list of like the most highly cited Viz papers.
You can't just talk to us.
But if you could find that list, overviews would be the main theme.
Always ask Petra.
Yeah.
Okay, good, very good.
She's a co-author of yours.
Okay.
Well, and we all know the most cited visualization.
Which one is that?
VISUS surfaces. Multi-cube.
Yeah, I looked, I Googled, but I couldn't really find that. Like there, I
It
remember.
was not sold as visualization back then. It was in SIGGRAPH. Should I say?
Yeah.
Bob wants to have an overview.
No, I tried. I could have tried harder, but like I remember a list of the most highly cited SIGGRAPH papers.
Yeah.
I remember it being on that list,
Mm-hmm.
but I was trying to find something specific for this claim. And then I'm just leaving this here because it's really like this. It's really could be another talk, but I'm just going to mention that the best overviews are scalable, right? And this is kind of, this scalability aspect is what inspires so many visualization problems, is that scalability. How do you generate a visual representation that provides both an overview and is scalable? This is basically one of the fundamental, this is the holy grail of visualization, essentially. That's my basic hypothesis. As a side note, dashboards are very popular because they are an attempt at providing an overview. That's one of the reasons why they're so popular. Okay, and then research papers themselves, right? Surveys. I think this is less controversial. Surveys are generally more highly cited than standard research papers because they provide an overview, right? That's the basic idea there.
How's the citation count on your survey of surveys? It should be enormous, right?
I was going to mention that. I wish this one got more citations, actually. That didn't turn out the way I was hoping it.
Maybe you can overdo it with overview.
Yeah, so feel free to cite this paper. Do I have anything else? Okay, so in summary, overviews are the holy grail of visualization. They're the overviews are the most important. They're the most in demand. They're very interesting. And they're very challenging, and therefore they're the source of a lot of inspiration for our field. Okay, thank you.
Okay, thank you, Bob. So, I think there are people in the room who can argue about scalability.
Did you see our paper?
So let me challenge you first. What is overview in direct volume rendering? It depends on so much on the transfer function.
It does. I mean, my knee-jerk reaction is an overview in volume visualization could be impossible. It could be like an impossible to solve problem. But I think a nice overview is just a visual representation of all the gradients in a volume, right? Because usually the gradients are the most interesting subsets of a volume. So anything that shows all of the gradients would be an overview for volume visualization.
Could be behind another gradient.
Yeah, no, I didn't say solved, like this is a solved problem. I didn't say that. I didn't say this is a solved problem.
Okay, open to the public. Questions, please.
Yes, I was wondering, like these overview visualizations that you've created for scientists and companies, like what was the result of that when people started working? Like what was the outcome for the people working with those?
So I can say that in a lot of our collaborations, we were the first people to show an overview at all. So I remember, especially with QPC, they did some experiments and they always had to take very small subsets of their original users. So they might have 300,000 calls in a day, and they would take a random sample of 2,000 to try to get a visual representation. And I would say one of the results is at least they could confirm their suspicions. They had suspicions, like we think this is what's happening, but now they could actually back it up with evidence. Like, we think that a lot of people are hanging up early at this time, but we're not sure, right? So they could confirm a lot of their suspicions. And of course, there were some new things. We didn't solve the world's problems, but so one new pattern we picked up is at lunchtime, there's a sharp rise in abandoned calls, and we believe it's because there's a shift in call center workers at 1 o'clock. So at 1 o'clock, one set of employees goes, one set of agents, and a new set of agents comes in, and it causes a lot of abandoned calls. But it's usually the kind of confirmation of something that they already thought or imagined was happening, but they weren't sure. That's usually the result.
Good, who else?
So following up on my question from before, I think a very critical component of creating overviews is aggregation. And aggregation is often tied in with a task. So a really good overview, for instance, is a box plot, right? But it's highly aggregated, but it really works well. Or just like, mean and a confidence interval, if you want to go inferential, right? And they're super, super successful, I would say, but they're tied to like a certain thing that you can do. And I think dashboards are also a good example. If you go 2 slides back, that's what we see.
Yep.
They do like a highly aggregated version of the data, right? But like, the aggregation, I think, is tied to, like, I know what I'm doing. So my task is more specified versus like, ill-defined tasks that we, exploratory tasks that we usually define or find in visualization, right? And I think like, maybe you can just elaborate, like when you were in your corner, did you think about aggregation?
Excuse me while I go hide in the corner. I've thought about that. So we could reformulate the question and say, for all the scalability, inherently tied to scalability is some level of abstraction, because you only have so many pixels. Imagine you have, 1 million pixels or something like that, but you have more than 1 million data samples. You need to provide some aggregation, and that aggregation results in some level of abstraction or clustering or whatever, aggregation or whatever you want to call it. So reformulating the question would be, what is the right balance between an overview that contains detail and abstraction? Right? Because you have to have you want to have some balance. I don't like these dashboards. I don't like dashboards, period. Like, I don't like them. And I think they're too abstract, at least for my taste. I don't actually like bar charts and pie charts and okay, line charts are okay. I think they're too abstract. And I want to see more detail. I don't think they provide an effective overview. So yeah, the question is, what's the best compromise between providing an overview with the right level of detail, but at the same time abstracting to support scalability? That's really the fundamental question.
I would support Michael's claim for a task, or sort of what is your information need. On a very general level, I could say, the world out there is complex. Can you give me an overview? And you would immediately say, well, exactly. What actually do you want to know? So without specifying
a task,
need.
A task.
And so sort of the box plots and the confidence interval, they work really well because it's very well specified what you're looking for. Like, it's a one-dimensional distribution where we assume like there's a normal distribution and then it's a really neat summary. We don't need hypothetical. No, okay, I'm not talking about that. But, the animated plots, that's something obviously. Anyways, but I think Daniel has a question on scalability here. Otherwise,
of course we have to define scalability.
I'll add one other tangential observation. It's not like a direct answer to this question, but I believe it's relevant. And I don't know what your experience is, but in my experience, when I'm coupled with a new collaborator, the task is undefined actually. So if I start a collaboration with QPC, at the beginning, the task is just undefined. Their attitude is, we don't know anything about visualization. Can you just show us what's possible? Because we don't know how to specify what we want, right? So that's kind of a counter-argument. And if I came back and said, here's my dashboard, I think they'd be really disappointed. Like, really? We don't need you for that. We can make a dashboard. So that's been my experience.
Right, so I agree, but like it's a back and forth, right? Like it's a design study where you work with people and you show what's possible, and they're like, ooh, and then they start like elaborating on their tasks.
Yes,
because if you work with like engineers at AVL, right? Like and they're working in engine design, you already have certain assumptions on their tasks, right? They might be wrong, but like that's how you look at the data, how you provide the overview. You show what's possible, and then they tell you, well, that's great, but it's not the thing we want to see. And then it's coming back sort of like to the question that Zita asked. But let's talk about scalability.
Yep.
You want to ask?
Yeah, you can. Well, you should define what's your definition.
What's your definition of scalability?
Oh boy, so
You can refer to a famous paper by Weisskopf and friends.
I should have read that paper. I have a feeling I'm one paper behind.
So many times.
I think the time is over.
I don't know, I'll try to answer it. It's just the ability to represent the whole data set. So something that can adapt to varying data set sizes, right? Especially increasing data set sizes.
So you say it's O of 1?
Say
The
that.
output size is O of 1? It's independent?
The output size is independent,
Of the
maybe.
input size?
For me, scale.
Dashboard.
For me, okay, that question has some subtleties to it. For me, when I think scalability, I'm automatically thinking hierarchical. Like, it has to be hierarchical. It has to be able to represent data at multiple levels of magnitude or size, multiple resolutions. But maybe that's a biased answer. Maybe it's because I'm from the Sci-Viz, like old Sci-Viz thinking. Does that answer the question? Did I pass? What did I
Passing rate? C minus? No, A minus, A minus.
I have to. What's the paper I should read?
It's called scalability.
It's just that's the whole title.
Visualization.
You're going to be at Euroviz?
Yes.
It's going to be presented there.
Okay. So it hasn't. It just got published.
PVCG paper.
PVCG.
Okay. So it's a new one. So I have some leeway.
Yeah, that's okay. There was a pandemic, yeah.
Okay.
So you should talk to this guy.
Okay. Good. See?
No, but my real question is, and resonates a little bit what we heard earlier. I think overviews are really boring because you only do them when you know what you're searching for. Because there was this nice paper by Liz Moran where she essentially advocated for bottom-up.
Okay.
The other one is more top-down if you go.
Okay.
Because all scientific endeavors, you pick out individual examples, you see something, then you can aggregate later.
Okay. That's
Actually, bottom-up is the way to go, not top-down.
Okay. That's an interesting.
Unless you want to do, AI, where you can put it in and they can do a summary for you.
That could be a good panel. Like top down versus bottom up.
That's right.
So we can submit a panel proposal if anybody's interested. Yeah.
Well, you should. You had a panel each single base that I've been to.
We could have a debate about like which problem inspires more visualization solutions. For me, I just think that the top down is more inspirational. Like it's very challenging. Like I automatically want an overview. Maybe I've been conditioned somehow. But right now this is like what my mind seems to want.
Any more questions from yes?
There's also a question from the chat, so I just read it. Do you have any suggestions on which visualizations are preferred to provide an overview for multimodal data, that is data from image, plus text, plus sensors, plus motion capture, etc. For example, an experiment where human participants and their interactions, multimodal, with each other are recorded and later analyzed.
Yeah, I have an opinion on that. That, to me, that would be something like one of these visual analytics style interfaces with the multiple coordinated views. So I could have put a slide in there that said multiple coordinated views are an attempt to provide an overview from multiple angles. I could have put that in there.
I
Yeah.
think you are triggered Daniel again.
Did I upset somebody? That means I'm doing something right. If I trigger some discussion.
We have been discussing. Okay, yeah.
Yeah, your claim was that many popular visualization techniques are popular because they create an overview. Does also the opposite hold? So do you know of unpopular visualization tools that are unpopular because they don't provide overview?
German faces.
Can I rephrase it? Can you give an overview of unpopular visualization?
That would be a difficult. I mean, another interesting question would be: are there any overviews that are unpopular? I mean, that would be a slightly more interesting question, I think. To say, like, are there any unpopular viz techniques because they don't provide an overview? Probably there are hundreds or thousands of them, right? Because the average citation of a paper is 1 or something, right? Or who knows? But that would take a big literature search to try to answer that question. Yeah. Nothing springs to mind off the top of my head, let's say.
Any more technical or philosophical questions? We are open to everything. If this is not the case, let's thank Tom again for Okay. Are there any announcements?